Hello and welcome to Aerospace Testing International's podcast. I'm Ben Sampson, editor of the magazine. This month we're talking to Andrew Patton about ZeroAvia, a company that is developing the world's first practical hydrogen powertrain for use in aircraft. Andrew sits on the advisory board of ZeroAvia and has a strong background in aviation. But on top of that, he's worked for a number of years in Silicon Valley, including for Google X and Wing Aviation. So he brings a tech entrepreneur perspective to the aviation industry and its issues that you don't often hear. ZeroAvia itself is making good progress outside of what I would now call the mainstream of battery-based electric aircraft development. It successfully hit several developmental milestones last year, including the first hydrogen-powered flight. As you'll hear, the company is now maturing its technology towards making its first 300-mile flight later this year. Will hydrogen find a role in the future as an aviation fuel? Andrew certainly believes that it will, and with the big OEMs such as Airbus now looking into hydrogen again, it could be that ZeroAvia will be ahead of the game. Anyway, I hope you enjoy the podcast, and I'll speak to you on the other side. So I have with me here today Andrew Patton from ZeroAvia. Andrew, can you just tell me a little bit about your own background and what you do at ZeroAvia, please?
Absolutely. Thanks for having me, Ben. I sit on the ZeroAvia advisory board. From a background perspective, I grew up flying, still fly, studied aerospace engineering, worked at Boeing as a flight test engineer early in my career in tactical aircraft flight tests. So for me, that was the mainly Navy aircraft, so the F-18 Super Hornet, T-45, E-18 Growler, those types of airplanes. Subsequently, I did some stints in finance for tech companies. And now today, in addition to sitting on the board of ZeroAvia, I sit on some advisory boards of some other companies in the aviation space. So happy to be here.
Great, thanks. No, thanks for your time. It's great to speak to you. So you're a Silicon Valley guy and an aviation guy, by the sounds of things.
Yes, there are a few of us out there. So it's interesting to have a foot in both worlds.
Great. So ZeroAvia is a good fit for you. I mean, how did you come to have your role in the company? You're on the board, right?
That's right. I'm on the advisory board. So I was introduced to our CEO, Val Miftakov, through a mutual friend. So Val is also a pilot, and we have a number of pilots on the board as well and in the company. So I met Val through that kind of aviation connection, but was impressed by his vision for what could be done in terms of a sustainable propulsion option for manned aviation, which, as you know, has been kind of something that I guess the industry has not believed was reasonably possible for a very long time. And I think minds are starting to change on that pretty quickly.
So when did the company launch? When did you get involved?
I've been involved since 2018 now. I believe the company, don't quote me directly on this, but I believe the company dates from about 2016.
Okay, great. And could you just tell me a little bit about what the aim of the company is? I mean, how far are you going to go with the development of hydrogen aircraft?
Absolutely. So ZeroAvia's vision is to produce a commercially viable, scalable, zero carbon hydrogen electric powertrain. Mm-hmm. To be clear, for manned aviation scale aircraft. So all the activities of the company stem from that, encompassing engineering, R&D, flight test, and all the things that we've got running on the business side as well. We've got some exciting partnerships teed up with British Airways and some other top name carriers. We're having a special traction in Europe, which is a bit closer. More of these emission goals for commercial air transport are a bit closer to happening in Europe.
Right. Okay. Interesting. I mean, so there's a split of work there, isn't there? Because there's stuff being done here where I am in the UK, and also presumably there's a bit of work going on where you are in California, right?
That's right. The roots of the company really started in a place called Hollister, California, which is about an hour south of Silicon Valley, out in California's Central Valley farm country. But it has since the company has received sort of tremendous partnership opportunities in the UK, As you probably already know, the company is partnering is part of Boris Johnson's Jet Zero initiative to clean up the air transport industry. So in the UK, most of the company's operations have centered around Cranfield Airport, where they have re-engined effectively a Piper Malibu aircraft with a hydrogen electric powertrain and flown it.
Cool. And that milestone was when was that? Was that last summer that happened?
Last fall, yes.
Yeah. Cool. Okay. So I mean, so what's the split of work? What's happening? Is there a lot of are you flying aircraft? Are you testing systems in California, or is that just going on in the UK? Or
it's at the moment the engineering and development activity is focused in the UK, but we retain an operation in Hollister. We still have a electric aircraft in Hollister. It was actually our first aircraft to fly on electric power, also a Piper Malibu. In fact, you can kind of go on our YouTube channel and see a couple pretty cool videos of the initial airplane flying in California, as well as the new airplane flying in the UK. In Hollister, that's where we initially did some ground testing, which I can speak to in a tiny bit more detail, of the fuel cell before integrating it into the aircraft. And that first really happened in the UK. So the UK is really kind of the center of the of development, center of gravity for development of the company at the moment. But I would expect further activity in California to be coming in 2021 and beyond.
Okay, great. I mean, if we could just talk a little bit about some of the technology that's going into the Piper aircraft. I mean, a hydrogen fuel cell, it's more complicated than a battery. We're talking a little while about the pros and cons of each approach. But I mean, you are doing what you're doing. It can't be easy to integrate that into an aircraft, right? I mean, what kind of extra requirements have there been for testing that use of fuel and a hydrogen fuel cell in an aircraft? And you got to be pretty careful, right?
It's a good question and a good point. Fortunately for us, we're really standing on the shoulders of giants. As you're probably aware, the automotive industry has, over the past several decades, invested billions of dollars in commercializing hydrogen fuel cell technology. And so we have the luck of, being able to source, for example, standard compressed hydrogen tankage at, it's both at 300 bar and 700 bar pressures. Some of the plumbing is appropriate for our use in aircraft as well. And of course, the fuel cell itself is available as well. So the good thing about ZeroAvia is that we don't have to do core technology development around fuel cell stacks and safe handling of fuel. What we do have to do is optimize those specifically for the requirements of the aircraft application. Mm-hmm. So in cars, most commonly you can integrate a hydrogen fuel cell, which you can imagine, you've got hydrogen gas and air, or oxygen really, flowing through this fuel cell. And so it's a sort of, lowish pressure system, but you've got flow rates of different gaseous kind of, reactants going into the system. So in contrast to just an electric car like a Tesla, where you've got batteries and you can kind of, to a point, you can very rapidly ramp, for example, the power output as the driver demands it in use. For a hydrogen fuel cell, it's a little more difficult to do that. So in cars, what's typically done is it's kind of a hybrid electric arrangement. So you have a hydrogen fuel cell that's making electricity, but doesn't have a ton of room to rapidly scale to a driver stopping on the accelerator, for instance. So in the car, they would have a battery or small battery to basically be an accumulator of sorts from an electric point of view to deliver you power rapidly while the hydrogen fuel cell ramped up or down. We are a little bit less flexible in doing those sorts of things in aircraft because, we pay big weight penalties whenever we put a battery in. So ZeroAvia is developing, core technology, not only around full authority digital engine control, or FADEC, a common, obviously, acronym in the industry, but as well as sort of this, things that make it possible to certify these things. So again, it's not the core tech, but it's all of the things around it that make it possible to be a reliable, high performance power source for an aircraft.
Sure. So the power requirements are obviously going to spike during takeoff, right, and landing. I
Right.
mean, have you got any insight that you can share about how you're solving that kind of problem, or is it a problem? Is it?
It's a great question. I mean, there are good ways to kind of get around that problem. Some of the stuff is in development, and it's probably a little sensitive from an IP point of view.
Mm.
But one of the very cool things about modern digital avionics, especially when you can integrate them with FADEC, is you have a pretty good knowledge. The airplane has a pretty good knowledge of it could reasonably be able to anticipate where the power, where the sort of power demands are going to come from.
Mm-hmm.
So you can kind of do things with the fuel cell that might, for instance, set you up to provide additional power because you're able to anticipate it. So there's some cool work going on there. There's also some cool work going on with some densification. Densification is probably not the best word. More making the fuel cell lighter than it would be in an automotive application without, importantly, reducing any of the safety margin that the automotive guys have built into the system.
Because I saw some details last week about the fuel cell itself, the high point fuel cell that you'll be using, and that seemed quite impressive with the use of oxygen coming into the fuel cell there. That seemed pretty cool. When was the decision made taken to use that? Have you been working with those guys for a long time on that? It's obviously the most important part of the plane in some ways.
I apologize on that. I don't know the history of that particular partnership.
Sure, no worries. Okay, so you mentioned that some of the testing work that's going on. I mean, obviously, flight testing is great, but I also know it's very expensive. So I mean, how much work are you doing kind of on the ground and even further back in modeling and simulation? Can you give me an idea about what you're doing in those sort of areas at the moment at all?
A little bit. I can speak to it a little bit, but unfortunately not in a ton of detail. I can tell you that historically the company has spent a lot of time testing. I don't think bench testing is probably short selling, what was done, but that was certainly where it started. Back in the day, we had a bright blue El Camino, which is, if you know what that is sort of a hybrid between a car and a pickup truck from the 70s.
Right.
So in the back of that El Camino truck bed, we had our first hydrogen fuel cell, transformers, motor controllers, all that kind of stuff, hooked up to a full size electric motor of the size that would be needed to power the Piper aircraft, and a big propeller on the back. So this thing would rip down the taxiway at Hollister, with the propeller screaming. Right. We had some great fun, or the guys had some great fun using that as a test bed, so they could kind of basically put the car in neutral and drive the thing just with the propulsion from the electrically driven propeller. So that's where it started. It's progressed quite a bit since then, and I'm not going to pretend to be intimate with details, but yes, there's definitely a lot of work going on, both in software and ground-based test beds before they ever get to the airplane. Sort of standard risk reduction stuff, for aviation power plant development.
Sure. Okay. So how many people have you got working on the projects at the moment? Do you know? Is it? I mean, you must have. And I mean, how much confidence have you got in the guys working on it? You got some top experts in there now.
The team is growing very quickly, but we have some wonderful folks who have a lot of experience both integrating electric powertrains into automobiles, as well as from the aviation point of view. And that's sort of where really the magic is happening, that sort of joining of those two experience bases. As I'm sure as based on the work you do, Ben, there's aviation is a challenging place in some ways, because there's obviously a desire to go fast, which is very Silicon Valley. But there needs to be a very real respect for the risks that are inherent in putting these things in flying machines. And I think ZeroAvia is getting that right. They're proceeding reasonably. They're designing experiments to minimize risk and maximize the learning that can happen, and move down the development track, and burn down technical risk as fast as possible. But it's definitely an ongoing process. And I think that's a lot of, what we think about in terms of as we move forward to, try to keep the velocity high, while mitigating risk as cost effectively and as time efficiently as possible.
Sure. Okay. I mean, is there anything else you can tell me about the test program, the development and test program at the moment? I mean, what's the next big milestone coming up? Are there any big challenges that you can share with us at the moment? I mean, you've had coming off the back of a couple of successes last year. You've had some good successful milestones, but I mean, what are the guys kind of working on at the moment?
Well, we're building towards doing a 300-mile flight on hydrogen alone, which we've not done before. And that would be, when we pull that off, which we expect to do, this year, that will be by far the most commercially relevant, milestone for electric propulsion that has ever been demonstrated, because it will be demonstrated with an airplane that is capable of, carrying 6 people in it, right? So, although there obviously won't be 6 on that first flight, but you get the idea. Mm-hmm. So that is a big milestone, and getting there, venturing farther and farther away from the airport obviously requires, kind of further risk reduction in the power plant and, more hydrogen tankage on board and all that sort of thing. But we're confident that we can do it in 2021. We're excited to demonstrate it.
Have you got a test pilot? Who's flying the plane? Is it you or Val?
No, I did some chase pilot work early out here in California. Val was our first test pilot. Absolutely. Uh-huh. We do have a new person on the team in the UK who is an actual qualified test pilot now. Okay. So excited about that.
All right. Okay. All right. It's quite a progression from the truck, I guess, from the El Camino truck. Were you at the flights last year? And do you get to these big events when the maiden flights happen and stuff, and the test flights? Or
with COVID, unfortunately, I was unable to travel to the UK for these things. But like I said, I used to fly I've flown a chase plane on several occasions next to in the pattern, a Cessna 182. Off the wing of our original Piper Malibu aircraft. There's still some video from one of those flights on YouTube. But yeah, it's great. It is really amazing as a longtime manned aircraft guy. It's really amazing when you think about starting a piston engine, warming up oil, sort of all the things that you do as a pilot, as everyone does to start these things up, warm them up. Perform a run-up prior to flight and do all those things that are, effectively operational risk reduction mechanisms.
Yeah.
This motor it's literally the throttle gets bumped up and there's a whir, and all of a sudden it's just instant. It's magic.
Yeah.
So it's magic to see it. And it's, while the propeller itself still produces a lot of noise, it's obviously dramatically quieter, than a piston engined, equal air, piston engine Malibu.
Yeah, let's talk about some of the benefits that you see to this. I mean, obviously the move away from fossil fuels is a big deal, but it's quieter as well, right? It's because of the less noise of the engine. You talk me through some of the benefits and the decisions into backing this technology over batteries, basically. So
I would say the biggest, where I saw very eye to eye with Val was Val really took a first principles. Val is a physicist by training, mm-hmm. and he really took a very first principles approach to the challenge of going to developing a zero carbon power plant. Mm-hmm. And so, what do I mean by that? I mean that in general, successful aircraft, not only engines but successful aircraft designs have been built on the back of power plants that are highly reliable, highly performant, and highly cost effective. So it's difficult to walk away from the gas turbine world because the many, many tens of billions, if not, I would speculate maybe even $100 billion that's been poured into R&D over the past, call it 70 years of that industry is staggering. And the unbelievable things that have been done with the laws of physics and combustion and the learning that has been done is obviously, it's unbelievable. But if you take the tack, so it's obviously hard to beat those guys on reliability because they're pretty darn good. Performance, because you think of a GE-NX or a GE90, it's unbelievable the amount of power that single unit produces. And from a cost-effective standpoint, they obviously have supported, since the 747, extremely low cost, widely available jet travel. But if you want to move to a zero carbon source, hydrogen is really hard to beat because there aren't really great alternatives out there. Batteries are known to be very, very heavy. And if you look at the evolution curve of batteries, they're typically getting lighter from a kilowatt hours per kilogram basis at a 2 to 4% a year rate. And 4% is probably generous. So if you extrapolate that out and you look at the amount of specific power that a gas turbine puts out today, you've got an easy 20 years to go, easily, if not 30 to 40, before batteries could potentially be comparable from an energy per unit mass perspective. And that, of course, for airplanes is such a critical number. In the hydrogen electric powertrains that ZeroAvia is developing aren't on par with manned aircraft energy densities so far, but we think we can get there. So batteries are at least 10 times away, a factor of 10 away from where they need to be at parity with jet turbines. Hydrogen electric fuel cells are more like 3, depending on your assumptions, 3 to 4x in a worst case to 1.5x away from where they might need to be. Mm-hmm. So we think that there's possibility that we can not just possibility, but we can reasonably get there with a hydrogen electric solution. And in addition, we can provide, you asked about benefits, we can provide some really compelling benefits over time. These things will be even more reliable than gas turbines because they have fewer moving parts. The overhaul times for the fuel cells are, in most cases, 2 to 3 times higher. So instead of a $2,000 to $3,000 hour time before overhaul engine, we think we can do at least 5,000 at the start and possibly 7,000 to 8,000 over time hours. And we think that we can produce hydrogen at scale more cheaply than Jet A, which would be a huge, huge win for the industry.
Yeah, quite a lot to unpack there. To me, it seems like not only are you pioneering new technology, which is a tough job in the aerospace sector, but also you are setting yourself the target of also proving that you're better than an very established 70-year-old technology, yes. which is tough. So so it's a big job for the test and development guys to hit that. But do you see? I suppose you could speak to that if you want to, but also I don't think I need to educate you about the scale of the task at hand. But anyway, do you see hydrogen as the solution to everything in aviation in terms of aviation fuel, or is it part of the mix going forward, or?
I don't want to be, it's a great question. I don't want to be totally dogmatic and say that hydrogen is the only thing that's going to win. But I think that it has the best chance of all the technologies that I am aware of today. I do think these hybrid applications are just less interesting in aircraft, simply because aircraft have a hybrid application is great for like a very peaky power demand kind of application. But aircraft are much more level. You have a peak of takeoff and then you're kind of level for a long time, right? So I would expect hydrogen to win. I do think that hydrogen is not going to be the only player, though. I would expect other, especially hybrids with some level of battery to play as well.
Okay. If I could just pick you up on something that you did just say, Andrew, was about reducing hydrogen at scale, and the infrastructure and the fuel itself. Is that not part of this? Part of what ZeroAvia are working on that as well as a solution, part of the solution to that, or?
We are also taking a partnership approach to that. So there are people out there, that do make large scale electrolyzers to convert water plus electricity into hydrogen. We think one of the great things that's kind of happened over the past 5-ish years is quite quietly the cost of renewable power on average in the United States has dropped below that of conventional fossil fueled power. So we think that there's an opportunity, and that trend is expected to continue in terms of downward pricing. Mm-hmm. We think there's an opportunity to absorb some of the excess renewable power on the grid and use that to help create very low cost hydrogen fuel.
Okay, great. So, I mean, just one more question, really, on specifically on hydrogen and it's the way it's going to impact, or the way you believe it's going to impact the aviation sector. I mean, what sort of scale do you think? I mean, obviously, you're developing the powertrain, one of the first hydrogen fuel powertrains for an aircraft. I mean, do you see that technology being adopted? I mean, where do you see that technology being adopted first in the sector? I mean, do you see it being used on airliners one day? You know, what's the impact going to be?
Absolutely. I think we're going to see it first in, sort of 600, call it 600-ish horsepower to 1,000 horsepower applications, which is squarely in the Pratt & Whitney PT6 turboprop engine market.
Okay.
That's a sizable market on its own. And if all ZeroAvia could ever do was make a PT6 replacement that's cheaper to operate and more reliable, it'd be great business. But I don't think it stops there, Ben. I think we do scale, in time to 19-ish seat aircraft, which you can do with a PT6A type size application, and then on to regional jets, single aisles, and wide bodies over time. I think it will take a long time. To your, I think a point you made earlier in a question that you asked, it's, we're 70 years, right, of development, maturity, and confidence. So getting there is not only a technical issue, it's a regulatory issue. Part 33, which is the FAR that defines or regulates the design and construction and certification of power plants, doesn't say anything about electric motors or hydrogen or anything like that. So there's a regulatory issue there. And there's a kind of getting the industry comfortable and believing in what we can do. So it's a long haul, but I think the PT6 application is actually fairly close at hand, several years out.
Okay, great. We didn't really talk about the environmental issues and the importance to the longer term prospects of the aviation sector. But obviously, you would back that this is a step that needs to be taken in order to guarantee that, to enable that future for people to fly and goods and cargo to be transported around the world, right? We need to be more environmentally sustainable.
Yeah, we as a sort of percentage of overall carbon emissions, commercial aviation is something like less than 5% today, but the growth rate, projecting that forward is not a great situation. And so getting ahead of that early is one of the things that really inspired ZeroAvia to exist at all. There's a need to head this off, and we know it's a long term. You can't replace something like a gas turbine, tomorrow. So that's why we're trying to get in front of it.
So can I finish up just by asking a slightly cheeky question? And that is, I mean, obviously ZeroAvia compared to the bigger players, Airbus and Boeing, it's a startup. Do you think enough is being done elsewhere in the industry to really to push the agenda forward in this way, or would you expect the source, the disruptive technology to come from a startup?
That is a wonderful question, and I'm trying not to get on my soapbox on that one, but I do think that the big players can, the nature of how they work, how they motivate their people, the big programs they have to sustain. It's just really difficult for them to do innovative things with high risks of failure. It's not how they're structured. They're just way too mature for that. So yeah, I do personally expect it to come from a startup. And the good thing about the big guys is they have the cash and the expertise to really kind of help be the arbiter of what is a good technology over time. You've seen Airbus's very public announcement endorsing hydrogen as a future technology that they're very, very much believers in. So I do think it's going to come from a startup. I think that's a more efficient way, overall, for the big guys to actually get to go from 0 to 1 on this technology.
Okay, cool. Thanks, Andrew. That's all I need. It's really interesting to speak to you, and thank you for taking the time out to speak to me. Unless there's anything else that you'd like to add or get across to our readers.
No, it's my pleasure, Ben. I think it's going to be a really interesting time for aviation in general. The sustainable, like what we're in my opinion, there are going to be 3 really kind of exciting areas to watch, over the next 10 years. We talked about one, which is bringing sustainability into aviation. I think there's going to be a ton of really interesting stuff to see on the autonomy front, which is going to bubble up from the small drone world. And I think if 737 MAX and other things have taught us anything, there's a real need for, some level of, there are a lot of people doing a lot of good work in the regulatory and test and approval environments, but I think we're going to see some, real significant changes to how that gets done in the future. And I'm excited for that too. So those three areas I think are going to be a real interesting thing to watch. And, who knows, maybe you and I will talk about another one day.
Yeah, cool. Okay. That's great. Thanks, Andrew.
So there you have it. I'm sure you, like me, listener, will continue to track ZeroAvia's progress. It's a lot of challenges there, but they seem in the right place, in the right frame of mind to attack them. I hope you enjoyed that, and I hope you enjoyed it enough to subscribe. And I'm looking forward to the next instalment of the podcast when we'll be talking to Boeing about their program to encourage innovation through startups in the aerospace sector. Stay safe and have a great day.